Download this code from codegive.com, link in the description below. OK, let's dive into the complex world of latency management in real-time online multiplayer games. This will be a comprehensive tutorial, covering the causes of latency, techniques to mitigate its effects, and practical code examples to illustrate these concepts. Understanding latency, the enemy of fun. Latency, in the context of online gaming, refers to the delay between an action initiated by a player and the visual/auditory feedback they receive in response to that action. It's the time it takes for data to travel between the player's device, computer, console, mobile, and the game server, and then back again. High latency can make a game feel sluggish, unresponsive, and ultimately, unplayable. Sources of latency. Latency isn't a single, monolithic problem, it's the sum of several contributing factors. 1. Network latency, ping. This is the most obvious factor. It's the time it takes for data packets to travel across the internet from your device to the game server and back. Ping is usually measured in milliseconds, ms. Factors affecting network latency include distance. The farther the distance between you and the server, the longer it takes for data to travel. Network congestion. If the network is congested, example during peak hours, data packets might experience delays. Routing. The path data takes across the internet can vary, and some routes are more efficient than others. ISP, Internet Service Provider. The quality of your ISP's infrastructure can impact your latency. Wi-Fi versus Ethernet. Wi-Fi is generally less reliable and introduces more latency than a wired Ethernet connection. 2. Server processing time. The time it takes for the game server to receive a client's input, process it, example update game state, and send back the updated information. Optimizing server-side code and hardware is critical here. 3. Client processing time. The time it takes for the game client, your computer, to receive data from the server, process it, and render the updated game state on your screen. Optimizing client-side code and ensuring your device meets the game's minimum requirements are essential. 4. Input latency. The delay between the moment you press a button or move your mouse and the moment that action is registered by your computer/console. This can be influenced by the polling rate of your input devices, the operating system, and the game engine. 5. Rendering latency. The time it takes for your graphics card to render a frame. High graphics settings and a weak GPU can cause significant rendering latency. Techniques to mitigate latency. Now, let's explore the techniques we can use to combat the negative effects of latency. 1. Client-side prediction. Concept. Instead of waiting for the server to confirm an action, example a character movement, the client immediately predicts the outcome and displays it. This makes the game feel more responsive. Problem. The prediction might be wrong. For example, you might move forward and then suddenly teleport back a bit if the server disagrees with your predicted movement, due to network lag or server-side collision detection. Correction, reconciliation. To handle incorrect predictions, the client keeps track of the inputs it sent to the server and the predicted states. When the server sends back an authoritative update, the client compares the server's state with its predicted state. If there's a discrepancy, the client smoothly corrects its state to match the server's state, minimizing the rubber banding effect. Example, conceptual Python-like pseudocode. Explanation. Player.move, simulates the player's movement based on input. It stores the predicted position and the input that caused it in predicted _positions. Player.reconcile, when the server sends back the authoritative state, it iterates through the predicted underscore positions to find the one corresponding to the server's input. It then updates the player's position to match the server's position, potentially with smoothing to avoid jarring movements. It removes older predicted positions. 2. Server reconciliation asterisk. Asterisk concept asterisk the server stores client inputs and simulates the client's actions based on those inputs. This allows the server to more accurately determine the client's state, even if the client's network connection is unstable. The result is sent back to the client for reconciliation, as described above. This works hand in hand with client-side prediction. Asterisk how it works asterisk the server replays the client's inputs from the moment the server receives a reliable snapshot of the world. 3. Dead reckoning asterisk. Asterisk concept asterisk similar to client-side prediction, but used to extrapolate the positions of other players, not the local player. The server sends updates for other players less frequently, to save bandwidth. The client uses the received data, position, velocity, acceleration, to predict where those players will be in the next frame. Asterisk problem asterisk like client-side prediction, the extrapolation can become inaccurate over time, especially if players change direction or speed. Asterisk correction asterisk the server periodically sends updated position data to correct the client's dead reckoning. Asterisk example, conceptual. Asterisk explanation asterisk. Asterisk remote player update, calculates the player's new position based on its current velocity and the time elapsed since the last update. Asterisk remote player receive underscore update, updates the player's position and velocity with the latest data from the server. It might also include interpolation to smooth the transition between the predicted position and the corrected position. 4. Lag compensation, hitscan. Asterisk concept asterisk this is used primarily in first-person shooters to compensate for the delay in hit detection. When a player fires a weapon, example a hitscan weapon like a rifle, the server rewinds the game state to the time when the player fired the weapon, based on the player's latency. The server then performs the hit detection at that point in time. This means that you're effectively hitting the target where you saw it at the time you fired, even though the target might have moved on the server by the time your shot arrives. Asterisk important asterisk this can lead to inconsistencies if not handled carefully. For example, a player with high latency might seem to be able to shoot around corners. Asterisk simplified example asterisk. 5. Entity interpolation asterisk. Asterisk concept asterisk instead of instantly snapping to the latest position received from the server, the client interpolates between the old position and the new position over a short period of time. This creates smoother movement and reduces the jittery appearance of other players. Asterisk implementation asterisk use linear interpolation, LIRP, or more sophisticated interpolation techniques, example spline interpolation, to smooth the transitions. Asterisk example asterisk. Asterisk explanation asterisk. Asterisk remote player receive underscore update, sets the target underscore x and target underscore y to the new position received from the server. Asterisk remote player update, moves the player's current position, x, y, towards the target underscore x, target underscore y by a fraction determined by interpolation underscore factor. A higher interpolation underscore factor, closer to 1, will result in faster transitions, while a lower factor will result in smoother transitions. 6. Prioritization of data asterisk. Asterisk concept asterisk not all data is equally important. Prioritize the transmission of critical data, example player positions, actions, over less critical data, example chat messages. Asterisk implementation asterisk use techniques like QoS, quality of service, at the network level to prioritize certain types of packets. Within your game, you can also selectively send updates based on their importance. For example, only send position updates if a player has moved significantly. 7. Frame rate independence asterisk. Asterisk concept asterisk ensure that your game logic is independent of the frame rate. Use a fixed time step for updating the game state, rather than relying on the elapsed time between frames. This ensures that the game runs consistently, regardless of the player's hardware. Asterisk example asterisk. 8. Network protocol choice, UDP versus TCP. Asterisk TCP, Transmission Control Protocol. Asterisk reliable asterisk guarantees that data packets are delivered in the correct order and without errors. Asterisk connection oriented asterisk requires a connection to be established before data can be sent. Asterisk higher latency asterisk the reliability comes at the cost of increased latency due to error checking and retransmission of lost packets. Asterisk UDP, User Datagram Protocol. Asterisk unreliable asterisk data packets are not guaranteed to be delivered, and they may arrive out of order. Asterisk connectionless asterisk no connection needs to be established. Asterisk lower latency asterisk faster than TCP because it doesn't have the overhead of error checking and retransmission. Asterisk choice asterisk. Asterisk games that require reliability, example strategy games where every command is critical. TCP is often a better choice, even though it means higher latency. Asterisk games where low latency is paramount, example first-person shooters, fighting games UDP is often preferred, even though you have to handle packet loss and out-of-order packets yourself. Asterisk hybrid approaches asterisk some games use a combination of TCP and UDP. For example, TCP might be used for reliable chat messages, while UDP is used for player movement and game state updates. Libraries like eNet are popular for this approach. 9. Server-side authority asterisk. Asterisk concept asterisk the server is the ultimate authority on the game state. Clients should not be able to directly manipulate the game state without server approval. This helps prevent cheating and ensures consistency. Asterisk implementation asterisk all important game logic, example hit detection, movement, resource management, should be performed on the server. Clients send requests to the server, and the server validates those requests and updates the game state accordingly. 10. Region selection asterisk. Asterisk concept asterisk allow players to choose a server region that is geographically close to them. This minimizes network latency. Asterisk implementation asterisk provide a region selection option in the game's settings. Consider automatically selecting a region based on the player's IP address. 11. Bandwidth optimization asterisk. Asterisk concept asterisk reduce the amount of data that needs to be transmitted over the network. Asterisk techniques asterisk. Asterisk data compression asterisk compress data before sending it over the network. Asterisk delta compression asterisk only send the changes in game state since the last update, rather than sending the entire game state. Asterisk interest management asterisk only send updates to players who are within a certain range of each other. Code example, simplified client server using UDP. This is a very basic example, meant to illustrate the fundamental concepts. It's not production ready, but it shows the core ideas of sending data over UDP. Key takeaways from the UDP example asterisk. Asterisk sockets asterisk we use socket.socket, socket.af_inet, socket.sock_gram, to create UDP sockets. Asterisk CENTO, and REC-FROM, asterisk these methods are used to send and receive data over UDP. Asterisk unreliable asterisk UDP doesn't guarantee delivery. We use a timeout on the client to handle cases where the server doesn't respond. Asterisk basic client tracking asterisk the server keeps track of connected clients by storing their addresses. Asterisk simulated latency asterisk, not in this example, but you could add time.sleep on the server or client side to simulate latency for testing purposes. Asterisk threading asterisk running the server and client in separate threads allows them to operate concurrently. Important considerations. Asterisk complexity asterisk latency management is a complex topic, and the specific techniques you'll need to use will depend on the type of game you're building, the network conditions you expect, and the level of accuracy you require. Asterisk testing asterisk thoroughly test your game in different network conditions, example with simulated latency, packet loss, and jitter, to ensure that your latency mitigation techniques are working effectively. Asterisk profiling asterisk use profiling tools to identify performance bottlenecks on both the client and server sides. Asterisk game engine features asterisk many game engines, example Unity, Unreal Engine, provide built-in features for networking and latency compensation. Familiarize yourself with these features. Asterisk security asterisk be mindful of security considerations, especially when dealing with client-side prediction. Don't trust the client implicitly. Always validate client input on the server. Anti-cheat measures are often necessary to prevent players from exploiting client-side prediction. By understanding the sources of latency and implementing appropriate mitigation techniques, you can create a more enjoyable and responsive online multiplayer gaming experience. Remember to prioritize testing and optimization to ensure that your game runs smoothly in a variety of network conditions. Good luck.